So the next talk will be presented by Wojciech Indyk from Agora, and he will be talking about Tez, which means fast. So we can for Wojciech.
Thank you guys for coming here. As Szymon said, my name is Wojciech Indyk. I started my journey with Hadoop 4 years ago. It was at the beginning some research project on my university. Then I worked for Kruk SA, then for Telekomunikacja Polska, after then for Samsung, and recently, as Szymon said, for Agora. I would like to present Apache Tez, like the title says. Tez means fast in Hindi. So here's the agenda. I introduce evolution of Hadoop stack. Rafał actually present the evolution of Yarn, so I'm very glad you have background of this change. Then I'll present processing model for Tez. It's directed a cyclic graph. Then say something about architecture of Tez itself, of implementation. And after this, I follow with example of MapReduce implementation on Tez. Then some theory why the performance is better for Tez than MapReduce. Then some about special mechanism in Tez session. Then I show you some benchmarks I've done for some algorithms. And the last but not least, current status of Tez, what to do to follow Tez and do next steps with introducing Tez in your company, in your ecosystem. So, Hadoop 1.0 lasts for a few years, and it was composed, the main feature of this system was MapReduce, which was both resource manager and computation engine. After some time, community decided that MapReduce is too tight for complex processing, and decided to split MapReduce into resource manager Yarn and execution engine MapReduce itself. It is a chance for plug in some other computation framework into Yarn, like for example Giraffe, Storm, and also for Tez. Tez is another computation engine against MapReduce, and the basic question is, why to interest in Tez? The answer is, it's just the next generation of MapReduce. Why? I'll present it right now. The first is the concept of Tez. Tez is composed with vertices and edges, like in the picture. You can build very complex data flow. This approach is more elastic than MapReduce. If you use MapReduce, you have to mention that each job is composed with map and reduce. You cannot avoid, for example, map phase or do double reduce phase. Tez allows for this, and it's, as I said, dedicated for complex data flow processing. The main advantage over MapReduce is the data not have to be stored on HDFS between MapReduce jobs. It's also the other benefit regarding to optimization data flow in runtime. For example, you can imagine that you can reconfigure this graph according, for example, data size you process. Here is the situation, the more typical situation when we use Tez for complex analysis regarding to data tables analysis and do some operation like group by, join, etc. This situation is from Apache Hive, which is the main target of using Tez. Tez is focused on working with Hive. And how is it implemented in code, in architecture? As I said before, Tez is composed with two basic components, vertices and edges. A vertex is a just processor when we define how to process data inputted from particular source. Then we have edge, which defines how to communicate two different vertices. It means two different processors. As we can see here, it's a basic example when we just get the data from HDFS, like in MapReduce. Then we have vertex. This vertex can run multiple processors. These data are splitted into this processor. And then, after processing of this phase, we can put data according to particular edge to the next vertex. As I said, edge is just way of connection of two vertices and has particular properties we have to define. The first property is routing. We can set up one-to-one, where, for example, this first processor always sends information to the first processor in the second vertex. We can broadcast information or make scatter-gather like in MapReduce. The second property is scheduling. We can do it sequential. It means do all computation on vertex number 1, then do all computation on vertex number 2. But we also can do it concurrently, which means we can do it computation on vertex number 1 and vertex number 2 as well in the same time. And the third parameter is data source. We can just state if this data after computation will be persisted or ephemeral. Persisted, it means after the computation, data are still available for read. And ephemeral is after this computation, data can disappear because we don't need it anymore. And having these three components to just imagine how different, how flexible process we can done. Here is the example how to implement, how to simulate MapReduce behavior using these edge properties. If we just set up scatter-gather, routing, then sequential scheduling, and persisted data source, we just have edge like connection between map and reduce phase in MapReduce engine. However, we can also make any combination of these three parameters, and we have just huge amount of possibilities to use connection between two phases. Let's dive deeply in this architecture. As I said, the vertex is a component of processing. This vertex is composed with flexible input, processor, output runtime model. So we just have to define these three components, which is composed on single vertex. So, for example, if we want to simulate mapper behavior, we have a component input like HDFS input, then processor like map processor, and then output like file sorted output. So we have mapper in here. And similar if we want to create reducer. The other interesting thing in Tez is that this processing model is data type agnostic, so we have to cast all data coming into processor. The one disadvantage is that Tez API changes frequently from version 0.2 to version 0.5. It were multiple change in API, some agreement. So, for example, I think these exact names of components are different in current 0.5 version, but the idea is still the same. So, to just understand this way of processing, we use this simple simple model. So the last step of dive, so let's see the code. It's a little hardcore, but the main thing I want to show in this slide, it's Tez, it's not so scary. It's just simple. To run, code some processing, you have to define only 3 methods, where the first method initialize and the second handle events. You almost can skip these methods and focus on run method, which just process data. The input for run method is a map of input and map of output. Because Tez is flexible in way of multiple input, you can define multiple input into one processor, also multiple output for other processors. And if you define the context, you can send data to the other face. But I want to also show you in this code this data type agnostic property. You can see that you have to cast your input data to process. It's flexible, but prone to error. So if you defined processors, if you define your vertex, how it works, you have to define DAG, directed acyclic graph, to make a processing. So let's imagine the situation like in here. You have 2 jobs of MapReduce, 2 different jobs of MapReduce, and at the end you want to join these results of these 2 jobs. In MapReduce you need 3 different jobs running sequentially, but in DAG you can make it in different way, like in this picture. The benefit is you don't have to save intermediate data on disk. You can pass it between vertices. If data are able to store in RAM, you can store it in RAM. You spare some time. And this construction is pretty simple. Please look like here. You just have to create an object, and then create vertices composed with processor like an argument for this constructor. Then you have to define edges with these 3 parameters, like I said, for example, scatter gather, persisted data source, sequential scheduling, and defined which 2 vertices are connected. Also provide what is the input class and output class. And if you define what vertices and edges look like, just use this component, this object defined at first, and just run methods like add vertex and add edge. And here we are, just simple short code to make such complex processing. So what is the performance gain over MapReduce? How the benefit looks like? As I said before, you eliminate replicated write barrier between 2 consecutive jobs. If you have 1 job, then another job, and the 3rd job you want to use data previously, you have to save these 2 first jobs on disk and replicate it, for example, 3 times at default. So you have to spend time on saving this data on disk, but you need this data only for this 3rd job, not in HDFS, not in persisted data source. So it is the first benefit. It also eliminates job launch overhead over workflow. Why? Because if we have just MapReduce approach, the job starts, the containers are running, and then map phase and reduce phase are processed, and after the job, all components, all containers are shut down. Then if we have even the same job in the next step, we have to start all containers, then process data, and then shut down containers. Tez don't need to shut down containers between phases. Actually, Tez don't shut down containers between phases, so that we can avoid warm-up of containers and creation of containers. So, for example, if we have simple job, it lasts, for example, 2 minutes. Half a minute is spent on start containers and shut down containers. You have just spare 30 seconds per one job on just warming up machines. So if you have, for example, sequential processing of data, for example, 10 steps, you can spare a lot of time for warming up JVMs and containers and yarn and so on. And the third benefit is that you can eliminate extra stage of MapReduce in every workflow job. The most simple situation is you want to have processing flow like map phase, reduce phase, and the other reduce phase. So double reduce in workflow. If you want to implement it in MapReduce, you have to make map, reduce, then obviously map, and then reduce. You have map phase you don't need in actual processing, but MapReduce framework have to compose with map phase, so you have to run this map phase even if you don't need this phase. So Tez eliminates this extra stage, because in Tez you can just define processors or vertex like map, then vertex reduce, and the other vertex reduce. And the third property of Tez, very interesting, is Tez session. As I said before, each job, each processing need to run application master with manage, with JVMs, with containers, and after each processing step, each processing flow, you have to shut down application master, then ask yarn for another application master, and then start some iterations. But if you have similar resource, if you have, for example, the same size of processing and you want to do it consecutively, you can imagine that I want just one application master for the whole of this processing, because I know it's similar data to process, so I require the similar amount of resource in my cluster, so I don't want to shut down my containers after each job. I want to use in the whole complex phase. So it's supported by Tez session, and Tez session is very simple. You just to create an object Tez session with name, with application ID, and then session configuration. You can already start your session and put your DAG to the session and put another DAG to your session to use the same resources. And when you just stop your computation, you just need to run stop method, and it's all. So when to use session? As I said some before, you can imagine analytic task on the same data. When you dig in data, in the same data, you know you probably use the same resources on your cluster, so you also can warm up your JVM on the same data. You can also cache your data on JVM, and this processing will be much faster than MapReduce approach. The second thing is when your data flow are consistent with many sequential tasks. If you know this task is similar size, you can use your resources many times with the same application master, with the same containers. But also, the very interesting use of this session is iterative job. Let's imagine that iterative job use nearly the same resource size, because the for example, in graphs, if you process graph structure and calculate, for example, PageRank, you have the same amount of nodes to calculate and the same number of values of rank of a particular page. You just have to calculate another values in the next phase, but it's still the same amount of data. The second thing is you just have the same operation in JVM. So JVM is able to optimize their run to particular computation. So these two things can be supported by test session. If you don't shut down your machine, if you don't shut down your components, you can warm up your JVM, you can optimize your JVM to particular operation, and you know that your resources are enough to process because you still process the same amount of data. So when not to use tests, as I stressed before, you have to be sure that the size of problem is nearly the same for two jobs in test session, because when we just ask yarn of application master and for resources, we have particular number of resources, particular amount of resource for particular application master. So if we start the session with very small job, for example, on 1 GB of data, and in the same session we want to run job with 1 TB of data, probably this amount of resources assigned for 1 GB is not enough for 1 TB of data. So be aware that the size of problem is nearly the same or just similar to problem you resolve in the same session. So it's all of the theory. It will be any more theory in this presentation. So then example of using Tez in compared to MapReduce. I just implemented 2 graph algorithms, single source shortest path and PageRank. And I have 3 different data source. Not so big. The largest one, 31 GB, the smallest one, half of gigabyte. I have 14 servers at around 8 processor, 16 GB of RAM on each. And I have Hadoop Hortonworks 2.0 distribution of Hadoop. So let's see the result. The darker is MapReduce execution time. The other is Tez. As we can see, Tez is faster for each processing. However, the most interesting thing is that the smallest data set is at around 3 times faster than MapReduce in case of Tez. But Twitter dataset, the bigger one, is around 2 times faster. Why is the difference? As I said before, the main benefit of Tez using computation is warming up machines, starting containers, and in general setup of environment to processing. So if we have very small processing in each phase, it can occur that, for example, nearly half of time of processing is dedicated to setup of your environment. So if you have not so much computation in your job, this benefit is much visible. But if you have more computation in your job, if you have larger data set, when you have computed longer time, this impact on setup of your environment is less than in case of small resource. These 2 algorithms are iterative algorithms, so I also present a result for each iteration of processing, and we can see very clearly working of test session. As you can see here, the first iteration of Tez is much longer than MapReduce and much longer than the other iteration. Why? Because you have to start containers, warm up machines. So this setup is it takes much time. But if you still use the same resources negotiated in the first phase, you can just minimize this execution time below MapReduce time of processing. So, as we can see, probably if you don't use test session, this result can be even like in here, for example. But if you use test session and don't need to set up your environment, it's the benefit. So the conclusion is, if you have a long iteration processing in your problem, just use Tez. It's just the benefit according to a larger number of iterations. And there are similar results in single shortest path. But what I want to say is I work on graph problems, on graph processing, like social data, like connection between objects and interactions. So MapReduce is not optimal for this computation. And the dedicated solutions for processing of graph is Apache Giraffe. And I use also Apache Giraffe to compare it to these problems. However, I was able to run Giraffe only in this case of the smallest data set, because in the larger data set it was RAM memory problems with computation, because Giraffe is very much consuming of RAM memory. So the computation ended with errors. So even if we see that Giraffe, which is this result, is truly better than the other computation framework, if you have larger data set, it can be not efficient because of lack of RAM in your cluster. So Tez is a nice alternative to process of graphs. And the other very important aspect, a part of execution time, is scalability. So I just put these three data sets on these charts and compare scalability of PageRank, both according to number of objects in my graph, what I processed, as well as edges in my graph. So this characteristic is pretty similar. Both MapReduce and DAG, which means Tez, has nearly linear scalability, but we can see that Tez scalability is better because the increase of execution time is smaller in compared to MapReduce approach. So Tez is also dedicated for very large processing, like hundreds of terabytes of data, like this size. So it's why the focus is on Apache Hive. So what is the current status of Tez? Frankly speaking, it's still in incubation phase, so we can imagine that there are many errors, many faults, many problems with processing, with introduce it to production. But it's a very vibrant community and very fast development in this project. So a few days ago, there was decision of graduation of this project, top-level project. It, of course, is under Apache projects. So we can assume that it will develop even faster than until now. The second thing, as I mentioned before, the development is focused on stability on Tez. They want to just assure that that even you have a very large amount of data, you are able to process it on Tez without errors. And the consequence is also that they have to focus on DAG support, because they have to support better fault tolerance with checkpoints. For example, if you have particular processing, like in here, and for example, you have an error in this phase, you don't have to repeat all this computation. Tez just have to go back with one node, compute it again, and then try to restart this node. So if you have very complex processing and just fail one of these vertex, it have to be flexible and able to repeat computation only on this particular errored phase. Okay, so the very frequent question is, what is the difference from Spark? I actually asked this question a few months ago on Hadoop Summit in Amsterdam. However, the answer was pretty blurry. I just conclude what is Tez for and what is Spark for, and just make some conclusions. So Tez is obviously focused on large data rather than fast computation in RAM of small data sets. As I said before, the main focus of Tez is support of Hive for very large processing of data warehouses. And in my opinion, Tez is something between Spark and Impala. Impala supports mechanism for SQL-like question for data stored in Hive. And Spark supports execution framework, but very general execution framework when it's oriented on iterations and access to the data from RAM. And Tez is something before. Using Tez, you can model your problem like in Spark, resolve similar problem, as well as use Tez under Hive and use it like SQL-like queries. So if you are curious how Tez look like and do I speak frankly about this performance, and you want to run Tez immediately, you can install Hortonworks distribution of Tez and just change the configuration. There is execution engine configuration. You just have to switch yarn to Tez yarn, and you can run all your MapReduce jobs direct on Tez execution engine. There is something like translator between MapReduce and Tez. However, be warned that this connector is still in development phase. So, for example, counters are not implemented already in this solution. So, if you have counters in your MapReduce job and want to run without any changes on Tez, you don't have to access to counters. And also, obviously, if you use connector, there is worse performance in compared to a job defined purely in Tez with Tez API. So, what is the next steps with Tez? If you are interested in Tez, if you feel that your problem can be resolved with Tez, you can use Sandbox at first. There is a free distribution of virtual machine from Hortonworks. You just can create your own DAG, for example, based on word count example. It's very useful for, you just have to change some methods, some way of processing your data, and just see how it works. And then after you will be familiar with Tez, you can focus on Stinger. Stinger is a connection of Hive with Tez. It was delivered with Hive 0.13. It's like Impala in case of Cloudera. It means you can put Tez under the Hive SQL like model and use it for ad hoc processing and even processing of very large data set with much benefit in compared to Hive. Here is the link for Stinger project. If you are interested, just look at this page. There are a lot of information about Stinger. So thank you. I hope you have questions, maybe some comments, maybe idea.
I have a couple of questions.
Yes, please.
Right, so that was a very interesting presentation. I have some experience with Spark, so for me it was like interesting to see this in context of Spark, like how Spark works, etc. And I have a couple of questions. So the first one is that do you always have to describe DAGs by yourself, or does Tez have abilities to do it automatically?
Tez is able to do it automatically for Hive. You can plug in Tez under Hive, and Tez translates this SQL-like query to Tez and run DAG by itself. And the second interesting thing is that DAG, actually Tez, is able to modify this DAG flow at runtime. As I said, for example, according to data size and change parameters. So there is something like execution plan, like for example in data warehouses, execution plan for particular query.
Okay. And the second question, on one of the slides you mentioned that the prior Tez, you just change the yarn to yarn Tez and then run MapReduce jobs, but they don't have optimized DAG. They will just run one after another way. So each MapReduce job will be a separate node in the DAG, so there will be no benefit of using Tez?
No, actually it's for just simple processing, as I said before, because for each MapReduce job you have to negotiate particular application master and resources for particular two phases, map and reduce, and then shut down all and then relaunch all these nodes. So it's not optimized. It's not a translator to intelligent translation of MapReduce flows. It's just able to run single MapReduce job on Tez.
Okay, so sorry for stealing this question session, but just one thing, at least for now. So yeah, I just want to give my remark regarding comparing Tez to Spark, from my opinion. I think there's a couple of things here. Tez is extending MapReduce to do something in more optimized way. Spark is a generalization of MapReduce, so you don't have to do MapReduce. You can do just the map phase or filtering or whatever you want to. Also, Spark has totally different syntax. If anyone that was looking at Spark code, it's totally different syntax. Actually, there's word for this. You can describe the steps very easily, very concisely. And Spark has caching, very powerful caching abilities. And Spark has Shark, which is an optimized type as well. So I think that both creators of Tez and Spark at least had this in mind to optimize type. But
maybe the other thing is I want to ask you, because I heard that Spark works well for Scala API. However, for Java API there are some errors. Can you confirm it or deny it?
Why use Java API?
If you are familiar with Java and other ecosystem which is right in Java.
Of course, then I got different requirements. I never used the Java API. I can imagine using Python API because Spark provides it and it's nice. But having choice personally between Java and Scala, anytime, I would choose Scala if I can. But, yeah.
Okay.
So maybe that's because of that, like it's not very often used. And
yes, so maybe I just add the information I never said, that Tez API is in Java. I think there is no another language supported by Tez.
I feel like Tez is more like a middle layer.
Sorry,
I feel like Tez is more like a middle layer. It's not really like end product. It's not the user can actually use it like Spark. Like Spark is the end product. You can install it, you can use it right away, right? While Tez was more designed as an engine that you can plug into Hive, you can plug into Pig, you can plug in any end level engine that user will actually use it.
Yes, I confirm, of course. You can use Tez like execution engine, and it's just the focus on this aspect. For example, to just connect Hive to Tez. However, the benefit of Tez is you can just use Tez like by yourself and create your DAG if you have specific problem. If you, for example, can imagine that MapReduce is not enough for your data flows, and you, for example, have to create something like co-map or co-reduce operation, you can design it in Tez directly and use it then as an endpoint product.
It would be nice to see support for Tez in Crunch, for example, where you already have these high-level operands, right? For all of the call groups and filters and stuff like that. And I know there is a Java ticket for Tez in Peak. You said that Stinger initiative added Tez to Hive 13. But I feel like I know that people from Hortonworks they will be working on Tez in Crunch.
Could you repeat?
I know that people from Hortonworks will probably be working on Tez for Crunch. Apache Crunch.
I'm not sure if you say so.
Yeah, it would be nice to see more engines using Tez because there's value.
I also think I'm not sure about scale of data processing, able to process in Spark, how large data can it be. However, when I asked people from Hortonworks what is the focus of the Tez project, they said that the focus is the amount of data. This project have to be able to process any amount of data you can have in your cluster.
Well, Spark is not limited to like what can you fit in RAM. You can as well like to HDFS and behavior time on MapReduce. But yeah, just for the sake of saying this, so you're not limited with your memory. You can, if you can cache like 50% of your data, then you will still get a lot of speed up. If you can cache only 10% of the data, then well, you won't get much faster, but you can still run your jobs and they will behave like normal jobs.
Yeah, but the fact is that Hadoop, on the other hand, is like more well tested, like in this environment with lots of data.
I'm not so detailed familiar with code of Tez, with exact mechanism of processing. I suppose there are many mechanisms of error protection. And maybe here is the difference, but if you want to be sure, you just have to see in the code and see the difference. So there were 3 points, and I'm worrying about 4 points. Any?
You mean blames on Tez?
Okay, so I wait for comment from people from Hortonworks. I think they have many blames for me because they are much more familiar with Tez. They just develop a lot of things in Tez. So, thank you.